Howdy PreCal, it is Miss Kosh, and we are jumping in with our very first lesson of the year. We're looking at our function notation and that sort of stuff. I expect that you saw a lot of this in Algebra 1 and Algebra 2, and they probably maybe did some function stuff in geometry. But here we go. So once again, same math, here we go. A relation shows the connection between input, you know what? I did charge my Apple Pencil, between input and output values. A function is a relation shows the connection between input and output values. You know what? Let's change this sentence here. I'm working off of somebody else's notes, and I caught a couple things I wanted to change, and I didn't catch that. Let's say a relation is a function which has one output value for every input. Okay, so for each input value you have, you're going to have exactly one output. And we'll talk about this a little bit more as we keep going. The domain is the set of all, it's the x values, which are your input values, and the range of the set of all y values, which are your output values. Okay, we'll talk about discrete data and continuous data, or a graph is discrete. Basically, discrete means you have to pick up your pencil, and continuous means you don't have to pick up your pencil. So they say a graph with scattered points that may or may not show a direction or trend. So there's scattered points. It can be a discrete graph even if they're not individual points, and I'll show you one in a second that I would argue is discrete. Okay, so is it a function? So what we're looking at here is each input value here, the x value, has to have a unique output value. So what I see is I've got an input value of -1, 5, 8, 7, 5. Oh, I said 5 twice. Okay, do they map onto the same output value? No, they do not. So that is not a function. Okay, on this next one, we'll talk about the vertical line test as we're checking to see if it's a function. So if I draw a vertical line, let's see if I can do this, and pretend it's vertical, and then I drag this along, I should only hit my function in one place at a time. Okay, so this would pass the vertical line test. In my AP course, saying it passes the vertical line test is not sufficient. You would have to say, every input value has exactly one output value, or something like that. But is it a function? Yes, it is a function because it passed the vertical line test. Every input value had exactly one output value. Okay, now let's look at this one. I see 0, 1, 2, 3. Oh, that's nice. I don't even have to look at the output values because the input values they gave us were all unique. Okay, the next one, well, hopefully you notice that if I draw a vertical line, I have a point here and here, which means it fails the vertical line test. It is not a function. So what we might say is that the input value of 2 has 2 output values. I don't quite know what they are. Well, maybe, okay, let's look at this one. So here, do you see that it looks like I've got the point 1, 2, 3, 4. This is -4, -1, and then over here I have -4. This is 1, 2. I have -4, -3. And so I could say, no, this is not a function because the input value of -4 has 2 output values. One is -1 and one is -3. So it's not a function. Okay, let's see. Now, so domain we said was the input values. It's our x values. And so the little note that the other teacher wrote here for this one was that the domain is how far left and right. So on this one, and the range is how far up and down. It's the output values, the y values. Oh, you know, when I zoomed in, I discovered that there are arrows here. I could not see them ahead of time. Hopefully your eyes are younger than mine. And what I noticed, because we've got those arrows, my domain is going to be everything. So one way that we can write that notation is this is called interval notation. Or we could use set notation. The abbreviated way is just to say the set of all reals, and so we can use that fancy looking R with an extra line. That means all reals, or all real numbers is maybe a more sophisticated way to say that. So that shows us that it's all real numbers. So right there, I would accept either notation unless I specifically tell you what type of notation to use. So if I just say, tell me the domain, then as long as you pick a correct way to say it mathematically, I don't care which terminology you or which style you use. If I tell you use interval notation, use interval notation. We use interval notation a little bit more typically, but here we go. Okay, the range is asking us what are all the y values. Well, what I notice is that I'm including this y value here and then everything bigger. Okay, so in interval notation, I am including that, so I use a hard bracket on 0. If they didn't want me to include it, they would have to have made that an open circle, and they did not. And we're going from 0 to infinity, or you might say it's x is greater than, or no, it is not x. What should I have written? These are not x values for the range, these are y values. I was just testing you. Did I catch you? Y is greater than or equal to 0. Okay, the next one, okay, so look at this. This is where, this is an example of a discrete graph where they're not just made up of individual points, because what this is showing us, this is what we call a step function, and it's starting here and it cruises along until it gets, so it starts at 0, it cruises along till 1, but at 1 it's going to jump up, and then it cruises along, and then at 2 it jumps up, and then it cruises along, and at 3 it jumps up, and then at 4 it cruises along, and then at 4 it jumps up, and then we cruise along. We don't actually make it to 5. We get infinitely close, but never actually make it to 5. Right? Was that 5? 2, 3, 4. I think that is 5. But okay, so our domain are going to be the x values. Well, what we have is we have the x value of 0, and then we have every x value until we get to 5, but we don't have 5. Okay, so this graph, the domain, is going to be all the numbers from, it includes 0, but it does not include 5. So it goes from 0 to 5, includes 0, doesn't include 5. And I like to tell my kids, I'm not grading your handwriting, but I'm grading your handwriting. If it's not obvious to me that one is a hard bracket, is how I would say that, and the other is a soft bracket, then I'm going to take off points. Okay, so then my range is, well, what are the y values? Well, I started with a y value of 0, then I had a y value of 1, then I had a y value of 2, a y value of 3, and a y value of 4. And so I would just do the set notation and say, how much do I care? I think I would just say it's 1, 2, 3, 4. And I think that's the best. I mean, if I wanted to be a little bit more sophisticated, and I will talk to my, I'll talk to Miss Bellish about how sophisticated we want it to be. I would say y such that is a little, y is an element of 1, 2, 3, or 4. Maybe the better way to say that. Do you know what? I don't think we care. I think we are happy with this. If I change my mind, I'll tell you. Okay. The next one, my domain starts here at, I think this is -1, and then we go to +1, but you'll notice we did not include -1, and we do include +1. Okay, my range, so now I'm looking at, my y values, this is as low as -1, and as high as, let's see if I can count, 1, 2, hang on, 1, 2, 3, 4, 5. Okay, so did we include -1? Nope. Did we include 5? Yep. And so that would be our answer. Okay, the next one, or the last one here in this section. The domain, I see we've got x values. We are including this one at 0, and then we're going to positive infinity. And my y values, I see that we're including a y value of 0, and we're going to positive infinity also, because we have this lovely little arrow right here, and it's going to grow. It grows slowly. Hopefully you recognize that this is a square root curve. Ish. Yeah, probably. Okay, so our domain, we included 0, we went to positive infinity. Our range, we included 0, we went to positive infinity. Super. That's kind of fun. Okay, domain, so sometimes I'll give you an equation and ask you for the domain. And so there's two things that that will tell us our restrictions to our domain. And one of them is that what can we not do in math? We can't divide by 0. Okay, I tell a joke, and you'll see it in my classroom. I love the Chuck Norris jokes, so if you don't know what I'm talking about, look them up, but look up school-appropriate Chuck Norris jokes, because they're not all school-appropriate. But basically, the Chuck Norris jokes will be like, Chuck Norris doesn't do push-ups, he pushes the earth down. And Chuck Norris's tears cure cancer, too bad he never cries. And then there's some that aren't school-appropriate. But my favorite is that Chuck Norris can divide by 0. Because you can't divide by 0. And so I always say that when someone tries to divide by 0, I'm like, you're not Chuck Norris, you can't divide by 0. So that has been the running joke in my classroom for 20 years, maybe 25, I don't know. So the first thing we do is we can't divide by 0. Think Chuck Norris. If you don't know who that is, look it up. Anyway, there were jokes forever. And the second thing that we can't do is that we can't take the square root of can't square root a negative. Okay, if you do, you leave the real world. And when we're graphing, all of our x values and all of our y values have to be real numbers. Okay, so if we try to, we can say, so let's say, don't leave the real world. You got to stay real. Okay. I mean, that's just good advice. Don't leave the real world. Okay, whatever. So those are the two things that are going to restrict our domain. So when I look at this first example, here's f of x. On this one, you'll notice there's nobody, we're not trying to divide anything, and I don't see any square roots. And so there are no restrictions, so our domain is going to be negative infinity to positive infinity. The next one on G, I do see that we're trying to divide by something. Okay, and so what happens, this down here cannot equal 0. Okay, so what we can do is we can say, okay, what is the denominator, x minus 2? It cannot equal 0. So now let's solve for x. Well, if x minus 2 cannot equal 0, then x cannot, what do I do next? You know what? I'm going to show you every little step. I'm going to add 2, and I'm going to say x cannot equal 2. Okay, and so I can write my domain, I could say it that way, x cannot equal 2, or I could say it goes from negative infinity to 2. It does not include 2, which is why I use a soft bracket, then I use the union symbol to show that it goes from positive 2 to positive infinity. Okay, either of these notations is fine, unless I tell you specifically how I want you to write it. Okay, the next one, we have h of x, and on this one I see a square root. Well, you remember, there's nowhere we're trying to divide, so we don't have to use rule number 1, but we can't take the square root of a negative. Can I take the square root of 0? Come up with an answer. What do you think? What is the square root of 0? The square root of 0 is 0. So yes, I can take the square root of 0. So that means that I need anything underneath my radical sign to be greater than or equal to 0. Okay, so x plus 5 has to be greater than or equal to 0 because I can't take the square root of a negative. And so now what do I do to solve for x? I subtract 5 from both sides. And so I have that x is greater than or equal to negative 5. So that's one way we could write the notation. You could also think of it like this. Okay, so here's on my number line, here's negative 5. We can equal that, and we have to be greater. So when I draw this little number line, that helps me come up with interval notation pretty easily. I see that I need the hard bracket, and I see that I'm going to positive infinity. Back over here, we could say, okay, we came up with this idea of x can't equal 2. We could think, okay, well, what happens if I plug in 2? Well, 2 minus 2 is 0, and that is a problem. You're not Chuck Norris. You can't divide by 0. Okay. And then this last one, I called this one spicy. So this one has both situations happening here. Notice we have something dividing, and we also have the square root. So what's going to happen with this one, and this may be a little bit beyond the scope of our course, but if you're up for a challenge, keep listening, and if not, skip ahead a minute and then come back to the next part. What I would have to do is that this whole denominator can't equal 0, but this part has to be greater than or equal to 0. So what we'll do is we'll just say x minus 6 has to be greater than 0, which means add 6, add 6. It means that x has to be greater than 6. So if I put that on a number line, we're saying here's 6, we don't want to be equal to it, so it's an open circle, and we're going to be greater than 6, we're going to be bigger than 6, we're going that way. So we could say the domain is x is greater than 6, or you could use that notation 6 to infinity. I think I'd like you to practice interval notation the most, unless I tell you otherwise. Okay, and there's that one. Okay, let's keep going. Function notation. Hang on, let me see how much more do we have. Let's come back to the next video. Okay, like, subscribe, comment, let me know how I can help you. I will continue the notes in the next video, and the only way to learn math is to practice, so go practice.